Today we are going to discuss about the solution of the assignment number 6 and assignment number 7. So starting from our question number 2. Question number 2, as you know, that this is basically a dienone-phenol rearrangement reaction, and this is the dienone component of this particular reactant. And when this dienone component react with H positive, it will get converted into the phenolic component. So the mechanism start from the initial protonation of this particular oxygen with H positive and will form OH positive, and after that there will be delocalization of this double bond, and the delocalization of positive charge will be there. Out of this particular group attached to this particular benzene ring, this CS3 group will be shifted here, and when it will shift here, there will be a positive charge here, and then finally this H positive will get removed and we will get this product as our final product. So this is your question number 2, which is basically dienone phenol rearrangement reaction, in which this is the dienone component and this dienone component will get converted into the phenolic component. Now come to question number 2. This is particularly a substrate, and this substrate will undergo the Wolff rearrangement reaction here with elimination of this molecular nitrogen, and when nitrogen has been annihilated from this one, it will get converted into carbene. There are various evidences that will say that in Wolff rearrangement carbene will be formed, and there are some evidences which say that carbene is not synthesized in this case. So after formation of carbene, ketene formation will begin from this step, and from this step the ketene will be synthesized, and here is the formation of this particular ketene. And after formation of this ketene, there is another reaction, and that reaction is, this is the particular reaction in which we are getting this pH NH2 is here, which react with this particular ketene, and when it will react, this particular product has been synthesized as our B product. So this is question number 3. Now come to question number 4, which is a example of quasi-Favorsky rearrangement reaction. And when this reaction happen, basically this is a case when we have alpha and alpha prime positions, and at these positions there is no hydrogen. So when hydrogen is not present at these positions, generally the rearrangement here will be called as quasi-Favorsky rearrangement reaction, in which the hydroxyl group directly attack on the carbonyl carbon, and when it will attack on the carbonyl carbon, there is migration of this particular group and will form O negative, and from here this O negative will now come to form carbon oxygen double bond, and this particular phenyl group will migrate. The important point here is the stereochemistry of the particular component. The bromine, as you know, is present at the axial position, and the COPH is present at the equatorial position here. Now phenyl group is migrating, and it is attacking on the carbon which is bearing the bromine with the elimination of this particular bromine. So when the product has been synthesized, the product, the C6H5, the phenyl group, it will be at the equatorial position, and the new carboxylic acid group, it will be on the axial position. So this is the stereochemistry, which is very important part of this reaction. So basically this is a quasi-Favorsky rearrangement reaction in which this particular acid will be synthesized. Now come to next reaction. This is basically a case in which benzylic acid rearrangement will happen. The substrate is furyl, and this furyl will get converted into the furylic acid with formation of furylic acid anion. What will happen? The OH negative will first attack on the carbonyl carbon, and when it will attack on the carbonyl carbon, the bond will migrate to oxygen. When bond is migrating to this oxygen, O negative will be synthesized, and from this particular ring will get shifted to this particular carbonyl carbon, with formation of C double bond O, from which ultimately the H positive will be shifted from this one to this O negative, and this will form furylic acid anion. When furylic acid anion has been synthesized, after this we have H positive, and it react with this particular H positive, and furylic acid anion was get converted into furylic acid. So this is a case of benzylic acid rearrangement reaction in which the furyl was get converted into furylic acid. Question number 6 is a basic modification of kind of reaction. Basically, this is a reaction of Favorsky reaction, and this is a modification of that Favorsky reaction, which is called as the Ramberg-Beck-Lung reaction, in which we have S double bond O group, and alpha to this one we have halogen. So basically, if we have SO2 group and alpha to that SO2 group, we should have halogen as the leaving group. At that time, in presence of base, this type of substrate will first of all undergo deprotonation reaction. OH negative will first attack on this particular carbon, and hydrogen will be abstracted out, H will be removed, and it will form C negative. And after formation of this C negative, it will attack intramolecularly to this carbon at which bromine has been attached, and then it will form thiarine dioxide. And after formation of this thiarine dioxide, from this sulfur dioxide, SO2 will be eliminated out and alkene will be synthesized in this case. So basically this is a modification of that particular reaction, that is the Favorsky rearrangement reaction, and this is called Ramberg-Beck-Lung reaction. Now we will come to question number 1. In question number 1, again we have dienone-phenol rearrangement reaction, in which this is basically a dienone component, and this particular dienone component will get converted into the phenolic component through this is the path by which the reaction can happen. Either this CS3 group can migrate from here to this one, so you may get this product, and you may also have some rearrangement like that. This ring may particularly detach from here, and it may reattach itself to the benzene ring and will form this another benzene ring, and the connectivity is this one. So this product may also be synthesized, and this product is also synthesized in this particular reaction. So this is a case of dienone-phenol rearrangement reaction. So this is your assignment number 6. Now we will come to the assignment number 7, in which the first question is Manic reaction, and this is an example of Manic reaction in which we have unsymmetrical ketone, and this unsymmetrical ketone will react with, this is a secondary amine and this is your formaldehyde. So first of all, this particular secondary amine will react with formaldehyde and will form the iminium ion. After formation of this iminium ion, we have unsymmetrical ketone, and this will get converted into the enolic form. And regioselectivity is very much important part in this reaction, because this is a unsymmetrical ketone and enol can be prepared from the CS3 position and from this position. So regioselectivity in this Manic reaction is partly controlled by the preformed iminium ion in this case, and the conditions that we have taken. Generally, this is basically highly substituted enol will be synthesized in this case, and from this enol a reaction will happen. So this is a case in which the reaction is particularly happening at highly substituted carbon. So we will get two different kind of the product. The product number 1, it will be the major product, and the minor product will be synthesized from less stable enol that will be prepared from this CS3 and C double bond O. So one enol will be synthesized from here, and one enol will be synthesized from this one. So this particular enol will form the major product, and this particular enol will form the minor product. So this is the case of Manic reaction. Now come to question number 2, and this question number 2, again it is a Manic reaction, and this Manic reaction is basically a reaction of phenol with this is your secondary amine and this is your formaldehyde. So first of all, mechanism start with the reaction of secondary amine with the formaldehyde, and it will form the iminium ion, and after formation of this iminium ion, the phenolic group, it will react with that particular iminium ion. Now basically this is carbon alkylation is here, so this reaction is particularly helping in the C alkylation. So alkylation can happen at which position? This will happen at particular this ortho position, not at para position. So ortho product will be synthesized, in this case phenol. So this is the mechanism by which it is particularly attacking on this one. So this is a reaction in which C alkylation is happening with phenol by using this particular Manic reaction. Now come to question number 3. Question number 3 is basically Baer-Williser oxidation reaction, Baer-Williser rearrangement reaction we can also say, and this is here we will have to take special attention about the migratory aptitude, as this is a bulky group is already present, and this is a case of bicyclo compound, and when bulky group is present and these bulky groups are present at the exo position, so two different kind of the product will be synthesized. The regioselectivity will be controlled by the already group present on the exo position. So endo product will be the major product, means the oxygen supplied from the endo product, it will be the major, and exo product will be the minor product. So here this product will be synthesized and this will be the endo product, which is minor which is major product, and this one is the minor product. This one exo position is the minor product. Now the second reaction is the hydrolysis. So this is acidic hydrolysis. The major product will undergo the acidic hydrolysis, and when it will undergo the acidic hydrolysis, bond will be broken down and it will get converted into alcoholic group and carboxylic acid group. So this product will be synthesized from the major portion, and from minor portion this product will be synthesized. So this is your product from the minor position. So this product will be synthesized as a case of Baer-Williser rearrangement reaction. Now come to this one. This is a kind of substrate in which the first reaction is Friedel-Crafts acylation reaction. This is Friedel-Crafts acylation reaction, right? And when acylation is happening here, this particular hydroxyl group will directive influence of this particular hydroxyl group is at ortho and para position, so it will direct the incoming electrophile. So the reaction will happen at the ortho position and acylation is happening here, so it will attack at ortho position, COCH3 group, followed by oxidation with H2O2. Baer-Williser oxidation is here, and this is synthesized from second reaction, Baer-Williser reaction. And after this we have acidic hydrolysis, in which this particular that bond will be broken down and it will get converted into this alcohol and this acid as the major component here. So this is a case of reaction on the benzene, that is the Friedel-Crafts acylation reaction, followed by Baer-Williser rearrangement reaction, and then followed by acidic hydrolysis reaction, right? Now come to question number 5 of assignment number 7. If I am particularly talking about this reaction, this is a application of Cartesian rearrangement reaction in which we get alpha amino acid, and how the alpha amino acid has been synthesized, that is synthesized from the sequence of reaction in which the base is attacking on this particular compound, which is containing active methylene group, from which acidic proton will be eliminated out. When this acidic hydrogen has been eliminated out, it will form C negative, carbon ion will be synthesized, and this carbon ion, react with R of alkyl halide, substitution reaction will happen, and there is formation of this particular product as A. This A on reaction with hydrazine followed by reaction with nitrous acid will form acyl azide, and this is the substrate for your Cartesian rearrangement reaction, and this particular substrate will undergo thermal degradation in presence of benzene and H2O. So this particular substrate will get converted into isocyanate, and after this one, as the reaction is happening in presence of water, it will get converted into amine. So amine will be the final product. So this will be your B, C. And after this one, we are doing acidic hydrolysis here, and on acidic hydrolysis, this CN will get converted into carboxylic acid. So like this, you can prepare alpha amino acid from this particular molecule. So this is the application of Cartesian rearrangement reaction. Question number 6. In question number 6, we have ketone, and this particular ketone react with the Carros acid. So this is basically a Baeyer-Williser oxidation in which we have, the rearrangement, and this particular group will rearrange itself and oxygen will be inserted between this. So this is the mechanism in this case, that first of all protonation will happen at this oxygen, followed by attack of the oxygen to this particular carbonyl carbon, and then there will be a rearrangement of this particular group to oxygen, and then insertion of this oxygen and formation of this as the product. So this is your reaction, that is Baeyer-Williser rearrangement reaction, in which ester has been synthesized. So we should be very clear about the migratory aptitude of the reaction, as in that question we were talking about the bicyclo compound, but here we are talking about this particular compound, where the compound having more electron donating effects, that group will migrate, and migratory aptitude will be the tertiary alkyl, then secondary alkyl, then aromatic compound, then primary alkyl group, and then finally CH3 group. So here we will be very clear about the migratory aptitude, and in case of bicyclo compound, the migratory aptitude is affected by the groups, the structural properties or the groups which are already present on the bicyclo kind of compound. So that's all about your assignment number 7.